Hello, everyone. Welcome to our special presentation about the challenge Explore the Sky and Exoplanets. So my name is Julie. I'm the director of the program Discover the Universe. And with me is Marie-Ève.
Hi.
Marie-Ève is my good friend and colleague, and she's sort of the brain behind this challenge. I'll let her present most of the content today. But I just wanted to say welcome to all of you. I know not all of you could be live, so I know many of you will be watching the recording. So I'm really glad you're watching this. And we hope you managed to observe a bit of the different things that you had to observe in the sky. I know the clouds can be in the way sometimes in December, but this is to introduce the sky to you, and hopefully you managed to observe a few things. So for those of you who are live, I'll be in the background if you have questions in the chat. And there you go, Marie-Ève, the floor is all yours.
Okay, great. So I am so happy to be there with you today to talk about the challenge Explore the Sky and Exoplanets. This is an idea, and Julie said I am the brain behind the challenge, but actually I was super inspired by the work she did way before I arrived and started to work with Discover the Universe. So for the little story, I am an astrophysicist. I finished my PhD in 2016 at the Université de Montréal in Montreal, Canada. And afterward, I started working as an outreach coordinator for the Institute for Research on Exoplanets at Université de Montréal. But now I only work part-time there, and that leaves me time to work with Julie with Discover the Universe. So it's great. And Julie has always put a big emphasis on looking at the sky. There's even a module on the website that is called that way. So I was really inspired to start looking at the sky more carefully and just appreciate the little things, you know, the ones that you can appreciate by yourself without binoculars, without telescope. You don't need any special training to appreciate the things that we included in the challenge, and you can also appreciate them from the city. I live in Montreal, so the light pollution is a big issue. It prevents us from seeing most of the stars, but we can still appreciate a lot of things in the sky. And if you're like me, maybe in an urban area, I hope that this challenge helps you reconnect with the sky. But even if you are in the countryside and you have a beautiful sky, you know, sometimes we're like this, you know, we look at our phones, we look at our feet, we make sure we don't get hit by a car, and we forget to look at the sky and just appreciate the beauty of it and the connection we have with it. We often say that we are, I think it's stardust, right? Julie, we can say that, we are stardust. And I think looking at the sky regularly really helps us reconnect with the nature. So the challenge was built for that. So I'm super happy that you are with us this afternoon for us, actually. And we will talk a little bit about the challenge. So I hope you had time to start the challenge, but if you don't, it's perfectly fine. You still have a lot of time. This challenge will run at least up until the mid-January and even more. But afterwards, you will still be able to use most of the things you will have learned in this challenge to reconnect with the sky. So if you have started to look at the sky, you can tell us what you observed, what you liked, what was your favorite observation so far, or what surprised you the most. You can write it in the chat, or you can send us an email to tell us. We would be really happy to learn more about what you learned. And if you still haven't started, maybe it's just because it was not the time for you to start this activity yet, but maybe it's because you had a problem. So you can also write us and tell us what are the challenges you have with this challenge. So the idea was just to make a game out of looking at the sky. So you have 9 observations to make. We already sent you the invitation to do at least 1, 2, 3, 4, 5, maybe 6 of them, but you will be able to do them for most of the challenge. Today, I just want to say a few things about my 2 favorite observations for this challenge this year. And afterwards, we will answer the many very good questions that we received from you. So they are good questions and they will help you learn more about astronomy and also learn more from this activity. So the first observation that I really wanted to put an emphasis on is looking at the 3 planets, Jupiter, Saturn, and Venus. So you know probably that these are planets of our solar system, and that the planets of our solar system, 5 of them, we can see them with our naked eye. So the 2 other are Mercury and Mars, but they are not visible at this time in the evening sky. But we have 3 at the same time, and it's a very, very beautiful show every night. And it's been like that for a few weeks, and it will be like that for a few weeks, that we have Venus, Saturn, and Jupiter align in the sky. We suggest that you observe them last week, because the moon was like kind of traveling between the planets. So the moon is closer to us, so it moves quicker, and like every night it changes place in the sky, while the other planets they stay put a little more time because they are farther. But the planets are still visible. So if you didn't know about this, teachers, you can simply click in the presentations that we gave you, and it will bring you on a fabulous tool that is called Stellarium Web. I hope that you already had the chance to explore this tool, but if you haven't, you can do it now. It's great. It's a very useful tool. So I'll just adjust my screen so that we see very well the sky. So it's just a reproduction of the sky as it was on December the 8th at 5 p.m. This was the time where we suggest that you did this observation. But if we move to today, so we are now the 15th, you see that if we stay on the moon, because now we were on the moon, it changes the place because the moon is slightly to the east now. But if we come back, say on Saturn, and 1 day more, you can see the beautiful view on the planets. So Venus is the closest planet to us. It's a bit closer to the sun, so we always see it close to the sun. So if I change the time, so I can change the date, and I also can change the time. So I come an hour earlier, so at 4 this afternoon, and you can see, oh, Mercury is so close to the sun that we won't be able to see it, but you can see that the sun is setting close to the west, where I am. And then you can see that Venus will be visible super early after that. It's one of the first things, actually it's the first star-like thing that you will see in the star after the sunset. So it looks like a very bright star. A lot of people who see this think that it's actually a UFO, aliens, because they are not used to look at the sky. But maybe you are used to look at the sky, and you know that Venus is the brightest thing in the sky after the sun and the moon. So it's a very, very bright dot. You can even see it before it's completely dark, like way before. And not only Venus, but also Jupiter, because Venus is a planet about the size of the Earth, but it reflects very well the light of the sun. So the planets, they don't shine by themselves. They are not massive enough, but they can reflect the light of the sun. And that's why we see them shine in the sky. Venus is super close, about the size of the Earth. Then Jupiter is way bigger than our Earth. It's, I think, 11 times more bigger. So it reflects way better the light of the sun. So even though it's farther from us than Venus, it's still super bright, a bit less than Venus though. But you can also see it before it's completely dark these days. And then you need to wait a little more to see Saturn right between those two. So Saturn will be a bit harder to distinguish it from other bright stars, but these days, like, you know that it's between Venus and Jupiter, so it's a good trick to recognize them. And actually, Julie, I think it was one of the questions that we received, how to distinguish them.
Yes, exactly. Some people, some groups from Rockland, Ontario, if I remember right. Yes, we're wondering how can we tell them apart. So that's a good
Yeah.
time to explain that.
So I think I almost finished answering this question. Like Venus is really the brightest thing that you can see in the sky besides the sun and the moon. So that's how you recognize it. And then Jupiter is, I think, the next one. Maybe there's another star, but it's almost like it's in the top 5 brightest things that you can see in the sky. It depends on where it is on its orbit around the sun. But then Saturn, it's a bit harder. You just have to know, or you use Stellarium. But these weeks, you can know that it's between Venus and Jupiter. So you can maybe tell your cousin or your aunt or your grandparents about this. Oh, see this bright dot, it's Venus. And then the bright dot at the just above it's Jupiter. And if we look carefully, we will see something in between, and it's Saturn. So Saturn is a bit smaller than Jupiter, and it's a bit farther also. So that's why it's less bright in our night sky. So that's the thing that I really want you to see in the next few days. Take advantage of the fact that right now it's possible to see them all 3, because as we move, like if we, let's say we go to a 4:30, as we move closer to New Year, you will see that Venus will be closer and closer to the horizon. So at some point, it won't be possible to see it. We see Mercury rising, but Mercury is way harder to see than Venus. And you can see that the sun is still up. Huh? As we move the date, as we move from the winter solstice, now the sun will set a bit later each day. So at 4:30, it will be higher than it was that it is right now. So see that after the new year, it will be almost impossible to see Venus, but maybe if we're lucky, Mercury, but we'll see. So I tell you, you should look at this this year. And maybe you have the question, oh, why are they like that now? It's not the same year after year. So the planets, they move around the sun, and depending on where they are, they will do more or less of their paths around the sun during one Earth year. So if we look, for example, at last year at the same period, we had something very special. Jupiter and Saturn were almost at the same place in the sky. I mean, they were still around the sun, but for us, they became like they were almost at the same place in the sky. And if we look maybe next year, it won't be what we have this year, it will be different. See how, so this is in December next year. You can see that Venus and Mercury, probably we won't be able to see them, but Jupiter and Saturn, it will be possible. So this is the first thing that I wanted to tell you. Make sure to see the 3 planets in the sky, because it's a beautiful view. And then the second observation I wanted to talk to you about, I will just answer another question. We had a very good question about constellations, Julie.
Yes, you're right. Some questions, some students are wondering, like, are constellations real? Are they studied by scientists? So it might be great to explain that a bit better. What really are constellations?
Yes, and Julie, you can stay with me a bit, because I think we also had the question, what is your favorite constellation? So I would be happy to hear about your favorite constellation. What is it?
Well, I think my favorite one is the one you're going to show them, because I know which one you're going to show them, is Orion, but not just Orion. In the wintertime, we have many bright constellations and stars actually in the same part of the sky. I was looking at them last night and I thought it was really beautiful. So Orion, and then Capella, and then Pollux, which is one of the star in the challenge with Sirius. So anyway, this whole area, you might not know all the names I'm mentioning, but this whole area in winter. Sometimes people ask me if the stars are brighter in winter, and it's not due to the fact that it's winter and it's colder. It's just that this part of the sky that we see well in winter just happens to have some very bright stars in it. So they seem to stand out a bit more.
Yeah, that's awesome. So yeah, so my favorite constellation, I mean, I like constellations. It's great to learn more about astronomy, but I think one of my favorite constellation is one that is super easy to recognize in the sky. It looks like an M or maybe a W. So you can see it here. It's called Cassiopeia in English. I think it's the right pronunciation. Yes, okay, great. And this constellation, you can see it all year round. So that's why I like it, because it's always there. It's a bit reassuring, you know, in the summer, in the winter, you can always see Cassiopeia. So we didn't include it in the challenge, but I wanted to talk to you a little bit about this because of the question. So are constellation real, and are they studied by scientists? So maybe just a little reminder that a constellation is imaginary in some sense. So what is a constellation is that there are stars, and they are always the same pattern, or I mean more or less the same pattern in the sky night after night, and we can recognize patterns. So for example, this I would recognize it as an M, but the civilization that came before us, they also saw things in the sky, and I think for some of them at least, they were much more connected to the sky that we are. I mean, there were no television, for example, at night. So looking at the night sky was a very great show that they could appreciate. So they had a lot of imagination around this design, and they would link the stars in their head with imaginary lines like the ones that are shown here. So of course, if you look at the sky, you won't see any lines, but they are imaginary. And then we can imagine a drawing after overlaid on this. For example, when I look at this, I might see a snake. So this would be its head, and then its body, and then its tail. But you could look at it and see other things. What would you see when you look at this? So maybe mountains or pyramids, or maybe you would call this the M constellation also, because you are fan of having constellations that are super close to what they actually look like. Well, the Greeks and the Romans, from which we take most of our constellations now, the ones that are kind of the 88 official constellations that the International Astronomical Union use to, it's more to navigate the sky or to get used to the sky. Well, we have Cassiopeia, and I will tell you something else, but they imagine the princess, or I think a queen, the Queen Cassiopeia. I mean, you need a lot of imagination to see this. I mean, one of the stars is his breast, and the other its arm, whatever. But it's seated on a chair, and the legend says that this was a princess or a queen that was super a fan of herself, and she would look at herself all the time, like you can see here with the drawing. And she was punished for that, for her vanity, and she was I mean she had to be on its but I'm missing the words now.
She was punished for being on her so the punishment was to be on her throne upside down half the year.
Upside down, thanks. That's the word I was missing. So she would be upside down for half of the year. So this is in French, but in the summer she looks like a W, and in the winter she looks like an M. And a very important point about constellation, are they real? Well, yes, we imagine them, but I mean, they are real stars that we imagine drawings on them. The scientists, they don't really study them because it's more like a trick to get around it, like to recognize things in the sky and know your way around the sky. The stars themselves are not necessarily close to each other. So for example, here you can see one of the top of the mountain is only 54 light years away, while the other peak of the mountain is 615 light years away. So they look bright. Sometimes they look almost the same brightness. Sometimes they look different. The thing is that they are both different distance and different size and mass. So the more massive a star is, the brighter it is. So this one is probably a very, very big and massive star, while this one is maybe a little less massive and bright. So that's for the question. I think I answered all of the question, actually. Yeah.
About that one,
And
yes. Yeah.
yeah, so I wanted just before we answer more questions to bring your attention to Julie's favorite constellation, the constellation of Orion. The Greek and Roman, they imagined a hunter there. And you know that like the constellation that civilization imagined are really linked to what was important for them. So yes, in the Greek and Roman Empire, it was a hunter, but in other civilization, it might be different. So I gave you the advice to look at this after New Year. And the reason is that it's easier to spot because it will be higher in the sky. So this link is not working again, wonder why, but you can just type it here, Orion. And it's in English, so you can just type it. And then you can see that on January the 5th, it's not too low on the horizon, but if you would try to observe it, say tonight at 7, it would be much lower on the horizon. And this is normal. Huh? The stars that we see at a given time are not always the same. This is due to the motion of the Earth around the sun. So now you can see tonight, yes, you would see it, but it would be barely above the horizon. And this is just a simulated view, of course, like where I am, it's full of snow. It doesn't look like this, but you maybe have like a mountain here or a forest or a building. So it's not super easy to spot things that are super low on the horizon unless you are like in a field, like in a barren field where you can see very, very far on the horizon. So if you wait until after Christmas, it will be much easier because it will be much higher in the sky. And yes, the Roman, they saw it as a hunter. I personally, oops, I moved the atmosphere. That's not what I wanted. I wanted to remove the drawing. Okay, it still shows. Look at this. What I see here is, I would see more like I don't know that word in English.
An hourglass.
Thank you very much, Julie. An hourglass. So you can see here the part that is wider at the top and the part that is narrower in the middle, and then the part that is wider at the bottom. There are two very big stars that can be seen in Orion, Rigel, and Betelgeuse. Okay, I don't know the name of the stars in English, but they are big stars, and you can spot them very easily. And the 3 stars of the belt that can help you to identify it in the sky. And this is very beautiful. And if you live in a rural area, you might even be able to see a very not too bright, but and not too sharp also, but you could see the nebula, the Orion Nebula, just here. And you can learn more about the Orion Nebula in the text that we gave to you about the Orion. And then it will help you to spot Castor and Pollux. And Pollux is one of the observation of the challenge, because there is a planet around the star. So if you can find Orion, you will be able to see Pollux, and you will be also able to find the Pleiades. So Orion is one that you should not miss, and then it will also help you to make other observations that are in the challenge here and here. So that's the last observation I wanted to maybe put an emphasis on, and then we can continue with questions.
Perfect. Awesome, Maria, for this overview of my 2 favorite observations as well.
You
like
too,
the Orion region is always beautiful with the Pleiades. I love the Pleiades too. Yeah. And then the planets, of course, right now, like this amazing view. It has been cloudy a lot recently where I live, so I haven't been able to see them that much, but last night was beautiful. And now it's great because Saturn appears pretty much right in between Venus and Jupiter. So it's a pretty nice view. You can see the line of planets.
Yeah, and the fact that it's cloudy, I mean, we knew that it would be cloudy during the month December. It's always like that. Astronomers, they know we chose that month because it's fun, because of like the big holidays. You can share those observations with your friends, with your family. You maybe stay up later. The sunset also very early, so maybe it's possible when you finish school to do those observations. That's why we decided to do it, even though it's always a bit like that, cloudy, rain, snow. That's normal in December. It's part of an astronomer's life.
Yep, exactly. So we do have quite a few questions that some groups sent to us, and I'm going to start. I decided to change the order, so I might surprise you, Marie-Ève, but there's a big question that everybody wonders: is there life elsewhere? And I think that fits well with your job as an exoplanet expert.
Yes. I was asked lately a lot, what is my favorite planet? And I think it was even one of the questions, and I would start with that. My favorite planet is by far our planet, the Earth. And it's because it's the only one that we know that can sustain life as we know it. We now know a lot of planets. Of course, we know the planets of our solar system. Some of them we can even see them with our naked eye in our night sky. But we also know some planets that are outside of our solar system. We call them exoplanets. So exo means outside. So these are planets that are outside of our solar system. They are around other stars. So when you look, for example, at a beautiful sky full of stars, you can think about that. All these stars, they are sun, and they can have planets, and most of them do. So each of these planetary systems, they might harbor life, but we don't know. We are not able yet to figure out if there is life on other planets, but it's becoming very soon. So right now, as we speak, there are telescopes that are either in function or soon to be in function that will help us decipher if the planets that looks a bit like the Earth, maybe they are the same size as the Earth, maybe they are the same mass as the Earth, or close to the size of the Earth, or the mass of the Earth, but we don't know much about them. So if you take our solar system, for example, we have Mars and we have Venus. They are somewhat like the Earth, but still they are not a place that we would find super welcoming to life, at least not humans, and not any sort of complex life that we have here on Earth. So it's really important to do very detailed observations of the worlds of our solar system, but also of the worlds outside of our solar system to know, is there life there? And right now, my answer is just as good as yours, Julie, or just as good as any kids that are watching us right now. We don't know yet. So do I think that we will find life? I'm not sure. I think that there might be, but maybe it's too far. Maybe they lived 1,000 centuries before us, or maybe they will live 1,000 centuries in the future. Who knows? But we are actively searching for that, including us at the Institute for Research on Exoplanets at the Université de Montréal and other institutions in Canada.
I think what's interesting is that most astronomers I know anyway, and astrophysicists, hope there is life out there. I kind of wish we're hopeful that there is life. Otherwise, it's such a big universe for just one planet that has life on it, like the Earth. That would be like a famous quote from a movie. That would be an awful waste of space. But again, like I love Maria's answer because we don't know, and I think that's what's really fascinating with all that. We want to know, and we're hopeful there is, but we don't know yet. Okay, other questions. There was a group in Montreal that was asking questions about the moon, the sun, and the Earth, trying to explain a bit what they are in terms of objects, like the vocabulary. So maybe we could go to those slides.
Yep.
You have the Earth there somewhere.
Yep. Yeah. I'm finding the Earth, and you can start. I will let you explain that, Julie.
Okay. So the Earth is a planet. You might know that one. So planets are the big objects orbiting a star. We call them planets. So that might be simpler. They're all round, they're all spheres. So those are planets. Now, if something orbits a planet, instead of going directly around the sun, it goes around a planet, then we call those natural satellites or moons. And this is our moon. So our moon, that's its name. It's got a capital letter, moon. But there are many moons in the solar system because planets have many different moons or natural satellites around them. Something interesting, though, is that not only planets can have moons, but dwarf planets like Pluto is a dwarf planet. It has 5 moons at least. And even asteroids can have moons. So a moon is not just around, it goes not only around a planet, but it can go around an asteroid or a dwarf planet. Basically anything that goes around the sun or that goes around a star is called a planet, and something that is in orbit around that object, that's the moon or a natural satellite. They're similar words. It's just easier to say moons. And I love the image that Marie-Ève brought up here because we tend to think that moons are much smaller than planets. It makes sense that a moon orbiting a planet would be smaller than that planet. But if you look at all moons and planets in the solar system, you see that some moons are actually bigger than some planets. So Ganymede and Titan, right there, those are moons. Ganymede is around Jupiter and Titan is around Saturn. And as you can see, they're both larger than Mercury. So that might be confusing for you. Maybe you didn't expect that, to have moons, some of them being bigger than Mercury. And maybe you didn't even know about Ganymede and Titan. But if those objects were orbiting directly the sun, you would know all about them because you would have learned them as one of the main the planets that you hear about in school. So yeah, it's kind of interesting. So the sizes there. Look again at like Earth, and Venus is pretty much the same size as the Earth. Look at Mars. Mars is quite a bit smaller than Earth. Of course, these are real pictures of the objects, but put together on one, like in one slide. So they're not like, obviously the objects are not that close to one another. And there are many objects there. You can see our moon as well. So you can see the size of it. It's one of the largest moons in the solar system. And look at the end, like Pluto, again, look at Pluto, how tiny it is compared to the Earth. It's even smaller than our moon. That's part of the reason why we call it now a dwarf planet. We'll come back to that if we have time a bit after. But so we talked about moons, we talked about planets, and the sun is either of those. It is a star. So like Marie-Ève said, the sun is a star like we see at night. All the stars we see at night are suns, or the sun is a star. It's the same type of objects. It's just that the sun is much closer to us, so it appears bigger and brighter. But all the other stars that you see at night, you can imagine them as suns with their own planetary systems around them. Like, so imagine the solar system times, I don't know, 1,000 in that picture alone. Like, let's say there are 1,000 stars, then you're looking at 1,000 planetary systems like the solar system in that image alone. Whew, that's a lot. One thing I find very interesting is that we tend to, we say the sun is a star, but stars are not star-shaped. Can you go back, Maria, to the picture of the sun?
Yep.
So stars are big balls of gas. So they're actually spheres. So you see them as circles, I guess, in the sky. So they're not star-shaped at all, which is kind of weird when you think about it. We call them stars, but they're not in the shape of a star. But we say stars are like, have pokes like that just because they seem to twinkle in the sky, and it looks a bit like that, but they're not for real. They're circles, they're spheres. Oh, and one question we had as well was how they move. So if you want to stop the screen sharing for a second, it can be tricky to visualize in 3 dimensions how everything moves in the solar system. So we've talked about that quickly. So this is my moon. This is the Earth. These are pretty much the right size, one compared to another, but I would have to put the moon quite far away, too far away that, you wouldn't see anything. So that would be kind of boring. So I'm going to bring it closer. But the moon, I'll put it like that, it's easier. The moon goes around the Earth like this. Do you know how long it takes to go around? Once. It's actually pretty easy. It's pretty much 1 month. So month, moon, similar words. That's how long it takes for the moon to go around the Earth. And all this is moving and goes around the sun. So I don't have a sun in my model here, but the Earth is moving around the sun, and it has this little moon going around it as it moves. So there's a lot of motions in there and can get a bit confusing to visualize everything. I just want to show you another activity, and maybe we'll send you the link to this one. It's pretty simple. I like it because you have pins here where you can make all 3 objects move if you want. So the moon goes around the Earth. The Earth actually spins on itself too. It's a bit harder to make it move without having the moon move, but you can do that. And then the Earth moves around the sun. Now, of course, this is not to scale at all, but it can be interesting to create a model like this and have kids, and just like kind of play with it and remind yourself how long does it take for each motion that you can create on this. And someone might ask, well, does the sun move as well? Well, the sun does move. In our model here, we want to keep it fixed because it's the center of our solar system, but the sun moves in our galaxy and it also spins on itself like this. But you usually don't learn about the sun spinning on itself. It's actually kind of weird. It spins in about 27 days, but it doesn't spin like a big ball spinning, like, like the Earth, everything spins together, right? But the sun is a big ball of gas. So the center of the sun actually spins faster than the poles. So the equator goes faster. It goes in about 27 days, and the poles would go in about 40, 50 days. I'm not sure exactly. But what that means is that if I was trying to do that with my body, I would need my belly to spin faster than my head and my feet. And that wouldn't work very well because I would get all twisted very quickly. But the sun can do that because it's not solid. It's a big ball of gas. So there you go. Some information about the sun, the moon, and the Earth and how they all move around one another. And now let's go back to another question. Oh, a group from Calgary asks, do you think one day we will colonize the moon and Mars? So Marie-Ève, that one is for you.
Yes, and this is a very good question. So I think the moon and Mars are the two things that are like the closer to us and the more accessible to humanity. And as you may know, we already did go to the moon. Maybe you don't know that it's been a while since we've been to the moon. I think the last time was in 1972, if I'm right, Angie. So the entire Apollo program that brought people to the moon was 3 years or so. And then afterwards, it was put on the side to allow other missions to go. So we did a lot of exploration of our solar system with robots, with different kind of robots that are either go on the land, the landers, or that they move on planets. For example, Mars has a lot of rovers, and we also have orbiters around a lot of the planets and even moons. But still, the moon is super attractive, and it's really probable that we will go back. At least it's in the plans of many nations right now, including Canada, to go back to the moon and to bring rovers, but also to bring humans there and to bring the first female astronaut, because during the Apollo program, it was only men. Don't know why, but now it will be the first time a woman goes on the moon in the next few years, they say. Let's see how it goes, but the beginning of this it's already started. They started studying the various landing sites where they could go. It's super cold on the moon. It's not a place where you can live, like here on Earth. You need like very special suits. You need habitats where you will spend most of your time. You need special rovers. Of course, yes, there is less gravity, but it's like you see sometimes in the movies where you see the astronauts, they almost seems to fly between the steps they are taking. And it's like that because the gravity, the gravitational pull of the moon is a bit less than the one of the Earth because it's a smaller body. But it's not that fun for humans to not be in a normal gravity field, like the one normal being the one on Earth. So it's really difficult to get used to that gravity, but also like so just for our everyday use, like to walk around, to do our things, you need to adjust a bit. that seems fun enough, okay. But for our body, it's not good either, because our body was meant to function on normal Earth gravity. And when there is less gravity, a lot of problems can arise. Usually you might know also about this, like it's not good for your bones, it's not good for even your orientation, but I think the bones are a major thing. And also the radiation coming from the sun and other stars, and stars exploding elsewhere in the galaxy, and gamma rays and many different things in space. You don't have any protection on the moon. Here on Earth, we are so lucky to have our atmosphere, this very, very thin layer of gas that we breathe, but that also protect us. You might have heard about the ozone layer that save our skin from burning during the summer, but it's much more complex than that. A lot of the sun rays are blocked by the atmosphere, and it's a good thing. And a lot of other harmful rays and particles are blocked by our atmosphere. And then on the moon, and even on Mars, there is no such protection. It's worse on the moon, but still. So yes, we plan on going there. We even plan on having colonies in the future, but it's not easy to live there. So the moon is close enough. I mean, you can go there. It's not too long of a trip. It depends on how you go, on which orbit you reach the moon, but it's still close. But even to get to Mars, it's complicated. It's much farther, and most of the problems that needs to be solved yet about sending humans to Mars have to do with the trip. Having humans go to Mars is a bit like 6 months, 9 months trip, and having them in a small piece of metal going from one planet to the other appears to be something very, very dangerous. You need to find a way to protect them if there is a sunstorm, for example, or if there are harmful rays that come. And there are many other problems that needs to be solved. But I really like to see science fiction shows about this. Some of them are really good. Some of them are super imaginary. Sometimes I read books with my son and I'm like, no, this is not right. So maybe you can also say what is right and what is not. But the fact to have like special suit on Mars, this is super realistic. You won't be able to go out with a bathing suit on Mars. Never, unless you have a big dome that protects you somehow.
Yeah, we don't see your slides. I don't know if you're showing something right now, but we don't see it.
My God,
I have a feeling you were pointing at your screen, so I thought I would mention it.
Yes. Thank you, Julie.
Oh, perfect.
So this is the Mars colony, and you can see the special suits, and that means that you haven't seen the moon colony either, with the special suits and the habitats and the rovers I was talking about. So sorry about that. Yes, and you can see it's a bit similar. So on Mars, you need a longer trip, but you will still end up in small cans like that. You spend most of your time. It's a great endeavor for humanity, but personally, I would not like to go on Mars. It doesn't look like a very friendly place to be. I was told doing research about that it's much more convenient to go at the very bottom of our oceans on Earth than to live on Mars. At least you're close from the rest of humanity, while on Mars you are super isolated. But still, I'm pretty sure humans will end up on the moon, on Mars, and even farther, and it's in our plans right now. So if you are here and you listen, maybe you will be the astronauts who will do these complex and exciting missions, but they are still very hard to do. And I think one thing that we need to stress, there are no plan B for humanity. It's not a place where we can go if we screw things up here on Earth. There is no room for all of humans there. Like, I mean, everything will have to be brought there. It's not super, it's not a friendly place. So it's not somewhere we can go if things go wrong here on Earth. So we really need to pay good care to our super habitable planet.
Yes, definitely. So we're pretty much on time at when to stop, but there is one more question I think we should answer very quickly, because we get asked a lot, and many schools actually wrote that question. what's with Pluto, right? Why is it not a planet anymore? And because it's not considered a planet anymore, because sometimes people get confused and they think it's not in the solar system, or is it even there still? So if you want to go back to those slides, maybe we could explain that very quickly in 1 minute.
Yes.
Oh, yes. So here's Pluto. So Pluto, we didn't know what it looked like. So when I was your age, we didn't know what Pluto looked like because we had never been visited by spacecraft. And it's so far away in the solar system, we couldn't see very well. It's very well with telescopes here on Earth. So in 2015, so that's not that very long ago, that's just like 6 years ago, all that changed because we had the New Horizon spacecraft. So just a robot, like no one was in there, just instruments. It flew by Pluto. It didn't stop. It just went by very quickly, took some pictures and kept going. And it took those amazing pictures. So it was very exciting for me actually to see Pluto for the first time. I had never seen it like that. Well, no one had. And turned out that it's a very interesting world, but it is very small. I showed you earlier how small it was compared to the Earth, for example. So for many reasons in 2006, yeah, there we go. We see it again. So Pluto compared to the Earth, compared to other planets. So now it's called a dwarf planet. But you know, when scientists discover objects in the solar system, they don't have labels on them saying, hey, I'm a new planet, I'm a new asteroid, right? Those labels are all invented by humans. We categorize them. And at some point we realized that, wait a minute, like Pluto, it seems to be the weird category a bit by itself. But then we also discovered Ceres, no, sorry, not Ceres, but Eris, which this is the best picture we have of Eris, but it's pretty bad because it's so far away in the solar system. And Eris seems to be pretty much the same size as Pluto. So what do we do then? Do we call it the 10th planet? What about Makemake and Haumea and Ceres, other objects that we see in the solar system that are small but still circular, like they're still spheres, but they're much smaller than the other planets. So instead of adding to the count of planets, we just decided to create a new category and call them dwarf planets. It didn't change anything for them. Like Pluto doesn't care, right? Pluto is still going around the sun, same orbit as before. It didn't change at all. It's just the way we categorize it that has changed. But sometimes I think, and that has to do with the way we teach solar system. We say the solar system is the sun plus the planets. And then people think, well, wait, if Pluto's not a planet, then it's not there anymore. It's not part of the solar system. But that's not true. The solar system is sun plus planets plus dwarf planets plus hundreds of moons plus comets plus asteroids. There's many things inside a solar system, including dwarf planets. So these are the 5 ones that have been categorized officially as dwarf planets, but there are probably hundreds of other objects that could fit in that category that just haven't been officialized yet. So that's why Pluto is not a planet anymore, but it's still a very interesting world. I love the geology on Pluto. We discovered it was like there's ice and there's ice mountains and like 3-kilometer high mountains of ice. I love that idea. And that was kind of a surprise when we discovered that on Pluto in 2015. So very interesting to talk about, to study, to discover, to learn more about, but it's not considered a planet anymore. But it doesn't matter. Again, Pluto doesn't care. It's just a label. Well, thank you very much. I think we're pretty much on time. Yeah, so we're actually over time. So we're going to stop here, but thank you for sending those questions. There were many more we didn't have time to answer. And thank you for participating in the challenge. We hope you enjoy observing the sky. I'm very glad you were here with us today or watching the recording. And Marie-Ève, thank you for all your explanations, and I will leave you the last word.
Yeah, well, I just want to say, as we say often, Julie, let's look up, let's reconnect with the sky. It's such a beautiful show, and it's there and it's free, and it helps us understand our world and our universe. So let's look up at the sky and just enjoy this precious view.
Great, thanks everyone. Bye-bye.
Bye-bye.